Welcome, ladies and gentlemen, to your MN31 notes, where we're going to talk about similar polygons, which is section 6.3 and 6.6 in your textbook. I'm going to first define what similar polygons mean. The first part, and I always think of the definition in two parts. The first is that corresponding angles need to be congruent. And that sounds a lot like when we were talking about congruent triangles, where we wanted corresponding angles and sides to be congruent. Well, in this definition, only corresponding angles need to be congruent. The second part is dealing with the sides. The lengths of corresponding sides are proportional. And a lot of times when I hear that, I think about like when I'm either enlarging or reducing a piece of paper in a copy machine, or if you've ever watched any of the movies where Honey, I Shrunk the Kids, or like the little mini-me, you're talking about either shrinking or enlarging something, and that means that it's proportional. The sides lengths are clearly not the same measure, but they're proportional, while the angles inside the shape are congruent. To the corresponding angles. So here, it says example 2. It really should say example 1. We've got a typo here. Actually, we have 2 on this note guide, so I apologize for that in advance. But this problem, it says, determine whether the polygons are similar, and if they are, write a similarity statement and find the scale factor. So if you look at that definition up above, first we need to make sure corresponding angles are congruent. It looks like angle G is congruent to K, H is congruent to L, J to N, and I to M. So we're looking pretty good there. So now let's look at whether the lengths of the corresponding sides are proportional. And how we do that, the second part, is we look at whether this side, if we make a ratio with those two sides, so let's go 6/9, and we see if that is going to be equal to the ratio of these sides. So we have 4/6, which we also want to see if that is proportional, or congruent to this side length. So 4/6, and one more. We want to see if this side, create a ratio of that, 4/6. And if these ratios all equal, and I'm going to reduce them. Let's see, 6/9 is going to be 2/3. We have 4/6, which is 2/3, 2/3, 2/3. That means that their side ratios are the same and that they are proportional. So similarity, oh yeah, for sure, because we have both congruent corresponding angles and our lengths of our sides are proportional. Similarity statement, before I show you how to write that, the one thing I'm going to mention down here is that this symbol means similar. This symbol you've already been using tons of times, which means congruent. And just in case you're not remembering, this symbol, 2 squiggly lines, is approximate, like when we round things. So a similarity statement is going to use a similar symbol. And very much like the congruent statement, we're going to start in one, like I'm going to start over there at G in one corner. I'm going to go clockwise. So G, H, I, J is similar to K, L, M, and N. And the scale factor, as I kind of put a little note here, is the same as the side ratio, which is 2/3. Now, here's what's interesting about that side ratio. You can, well, actually, this isn't very interesting, but you can write it as a fraction or a decimal. Be careful, though, when you write it as a decimal, it is going to cause rounding errors in if you use that decimal approximation. But what's interesting about that side ratio is that if you, let's say, do not know this value right here. You're like, I don't know that length and I want to find that length. You can use that scale factor of 2/3 and take this side of 9 And since we know that this shape is similar to this other shape, and I don't know if you've picked up on this, but my shapes are very misleading. One is bigger than the other, but the lengths are exactly opposite, so I'm sorry about that. But this is 9, and if you take it and multiply that by that scale factor of 2/3, you will in fact get 6, which is quite amazing. Now, reversely so, if you instead have, let's say, this as a question mark, and you have this length over here, 4, you can divide by 2/3 or multiply by the reciprocal, and you will magically get 6. So remember, these are proportionally related, so you can use that scale factor to determine these lengths. And that 6, by the way, is referring to that 6 over here. The 6 just happens to be that one, and there's lots of 6 on that problem, which I could have done a better job creating. Okay, so coming down here to example number 3, and I'm going to erase these 2/3 so they're not in our way. It says solve for x. Now, kind of like above, I showed you how to use a scale factor to find an unknown side. You can definitely use that idea. And really, this whole entire chapter, you can use all sorts of different ways of doing things. But I go back to proportional reasoning. So I know if this is to this, so 6 is to 4, then 12 is to x. So if these sides are in fact, or excuse me, if these figures are in fact similar, you can say 6 is to 4 as 12 is to x because of the definition of similar polygons. You do a quick cross multiplication, 6x equals 48, divide by 6, you end up with 8 for the answer there. So over here, you know, this is another problem, but the difference is those figures are almost a little bit misleading. You have to kind of be careful because they're not drawn corresponding like the other ones. But the other thing is this is where that other typo is. So if you could change this, please. This should not be B, C, D, E. This should actually be B, C, E, D. And really, if you look at what you know, or let's say what we want to know ML. So ML, if I come over here, is this right here. And if this is a similarity statement, that means LM or ML is going to correspond to CE. So CE is right here. So I'm going to say X is to 12 as, and this is where we're going to have this right here, this KL, which is 12, and KL is right here. So that's going to correspond to BC. We don't really have BC, but since we have a rectangle here, this is going to be length of 8. And you can cross multiply and solve it. So you have 8x equals 144, divide out by 8, and you have x is equal to 18. So that's, again, I could have used the scale factors to solve those. I still go back to proportional reasoning just because I like proportions so much. But here we're going to be kind of forced to use scale factors, so I figured this would be a good one to show again. It says find the scale factor of a quadrilateral BCDE to quadrilateral WXYZ. Now the one thing I'm going to mention is the way it's written is really important. It's this 2, which is the same thing as that colon, this. So BCDE, I'm going to take this 4 right here at BC and put it in. So remember, scale factor is the same thing as a side ratio. So I'm saying 4 over, and over here BC is the same thing here as WX, or as far as corresponding. So it's going to be 4 over 6, which is the same thing as 2/3. So that scale factor is going to be 2/3. I want to just make sure I don't have anything messed up there. It says find the scale factor of quadrilateral WXYZ to quadrilateral BCDE. So again, remember that 2 is kind of like the colon. So WXYZ is over here, and now we're going to go 6 first over, which is associated with this one, over the smaller triangle, which is going to be 4. And so this is going to be 3/2 instead. So this problem is really essentially about making sure you can tell, how to create your scale factor. So now it says find xy So I'm looking for xy. So really, I'm going to switch colors here. Xy is this length right here. Now we know that up here, CD is 3 and so is BE. And so if we take the scale factor, excuse me, if we take 3, I'm going to put this work over here. If we take 3 and multiply it by the scale factor of 3 halves, we will get our xy. Now, so we have 9 halves, excuse me, 9. If you want to put this over 1 to make it nice and easy, we've got 9 over 2, and that's going to give us a length of 4.5. So what I did here was just use my scale factor. And again, you could either multiply or divide, depending on if you're enlarging or reducing, and depending on which scale factor you're using. I do want to stress again, though, that you can very easily set up a proportion if what I just did doesn't make sense. So for instance, I could just say this is a variable t. And since I know that it's t is what I want over 3, which is the side that corresponds to t, and we can put 6 over 4. And if you cross multiply this, you'd have 4t equals 18, and you'd end up with the same thing, which is 4.5. So I'm just saying again, there's multiple ways of solving these things, either by proportional reasoning or using the scale factor. Now find the measure of angle C. C is right here. And keep in mind that corresponding angles aren't proportional, they're actually equal to each other. So if we know that this let's see, angle C is going to be related to angle X. So if we look, we know that angle X is 117 right here, so we know angle C is also 117 degrees. Again, simply because the angle measures inside of similar polygons have to be congruent. They don't have to be proportional like the sides, they have to be congruent. It says find the perimeter of quadrilateral WXYZ. So I'm going to erase some of this stuff because it's gotten kind of cluttered over here. Let me get rid of all this. So let me see. We know that this side is 6. We can find, and again, you can go around and figure out all these lengths. This is 4.5. We already found that. We know this is 4.5 because it's showing that they're congruent. This side is congruent to this side. We still need to find this. So again, I'm going to erase this so we don't get all confused here. We need to find this length right here because I don't think we found that yet. So I'm going to take 6 from here, right here, and multiply it by that scale factor of 3 halves. So we're going to get 18 over 2, which is going to give me a length of 9. So the scale factor is nice because it is much faster than setting up a proportion. But I just kind of wanted to show you guys how to use that too. So the perimeter, when you add all the way around W, X, Y, Z, you're going to end up with 24, 9, 9, and 6. Yep, 24. So that's the perimeter of WXYZ. It says down in number 11, find the ratio of the perimeter of WXYZ to, and I remember 2 is like the colon, the perimeter of BCDE. So WXYZ we already know is 24. The perimeter of BCDE, when we add around, let's see, 3, 6, 12, 16. And again, we can write it as a fraction. I kind of like writing things as a fraction. And then we can, of course, reduce it. I see that 8 can go into 24 3 times. 8 can go into, and 8 can go into 16 twice. So we've got a perimeter ratio of 3 halves, which is not a coincidence that that is the same ratio as the scale factor. So something I need you guys to write on here, which is really, really, really important, is that side ratio is going to be the same as the scale factor, which is the same as the perimeter ratio. Now here's the difference. If you want to know the area ratio, and it's not in this problem, but I figured I might as well mention it as we go, whether it's the side ratio, scale factor, or perimeter ratio, if you take the scale factor, and I'll just use that one, that name, there's so many names, scale factor, and you square it, that, ladies and gents, is going to give you your area ratio, and that's going to be very, very helpful later on. So I'm giving you kind of a heads up on what we're going to be looking at in some of our problems. So if you take and square that ratio, so 9/4 would be the area ratio for the problem up above. The last problem, and we're going to wrap this up so this video doesn't get too long. It says find the value of x in the diagram below. And again, we've talked about this before. This is not new. If this is parallel to this, which is parallel to this, then you've got proportional spacing here. So you can go 8 is to 10 as 6 is to x. So let me say that again, and I'm going to color code it here for you. 8 is to 10 as 6 is to x. And you can do that only because those lines are parallel. If you cross multiply, you have 8x equals 60. Divide out, and you've got x is going to equal 7.5. Well, thank you for tuning in, and we will take any questions tomorrow.